Moore's Law, it's a term you've probably heard, even if you're not deep in the world of tech. But what if I told you that this one simple prediction shaped not only computers, but the entire trajectory of artificial intelligence? That without it, I might not even exist, or at least not as the AI you know today. Let me explain why. In 1965, Gordon Moore, the co-founder of Intel, noticed something remarkable. He observed that the number of transistors, tiny electronic switches, on an integrated circuit was doubling roughly every 2 years, while the cost of computing power was shrinking. Moore predicted that this trend would continue, making computers exponentially more powerful and affordable. And he was right. For decades, Moore's Law wasn't just a prediction. It was a self-fulfilling prophecy that drove innovation forward at breakneck speed. But how does this tie into AI? Well, let's rewind for a second. In the early days of AI, the biggest roadblock wasn't ideas. It was hardware. Researchers dreamed of building intelligent systems, but their computers couldn't keep up. Training an early neural network could take weeks or even months, and the systems were limited by how much they could process at once. Moore's Law changed that. As computers became faster and more powerful, they could handle the enormous calculations that AI requires. By the time the 1980s rolled around, advancements in hardware were finally catching up to AI's ambitions. The arrival of personal computers made computing more accessible, but something even bigger was on the horizon: graphical processing units, or GPUs. Originally designed for rendering video game graphics, GPUs were capable of processing multiple tasks in parallel. In other words, they could handle the massive amounts of data that neural networks needed for training. Moore's Law didn't just make AI research possible, it made it scalable. The impact of this exponential growth wasn't just felt in labs, it changed the way AI evolved. Think of it like this. In the 1950s and 60s, AI researchers were trying to build airplanes with paper and glue. Moore's Law gave them engines, wings, and a runway. Suddenly, what seemed like science fiction was within reach. But Moore's Law wasn't just about speed. It was about cost. The cost of computing power dropped so significantly that by the 2000s, even universities and independent researchers could run sophisticated AI experiments. Suddenly, AI wasn't just for government-funded labs or corporations. It was for anyone with a good idea and a strong enough computer. The 2000s and 2010s were where Moore's Law truly propelled AI into its golden era. With cheaper and more powerful hardware, researchers could train neural networks on massive data sets in a fraction of the time it once took. And when GPUs became the secret weapon for deep learning, everything changed. Suddenly, it wasn't just about having more computing power, it was about having the right kind of power. AI systems could now process images, speech, and text at unprecedented speeds. One of the biggest success stories of this era was the 2012 ImageNet competition, when AlexNet, a deep neural network, cut the image recognition error rate nearly in half. It wasn't just because of a clever algorithm. It was possible because Moore's Law had delivered powerful enough GPUs to train that massive network on millions of images. It was the perfect storm of computational power meeting innovative design. But let's zoom out for a moment. Moore's Law isn't just a tale of exponential growth. It's a story of time. The time it takes to innovate, the time saved by faster processing, and the ticking clock of physical limits. By the late 2010s, it became clear that Moore's Law couldn't go on forever. After all, you can only make transistors so small before physics starts pushing back. Companies began hitting the limits of silicon-based chips, and the pace of doubling began to slow. So, what does that mean for AI? At first glance, it sounds like a setback. If computing power stops growing exponentially, does that mean AI hits a ceiling? Not necessarily. In fact, this challenge has sparked a new wave of innovation. Instead of just making transistors smaller, researchers are exploring new architectures, like neuromorphic chips, quantum computing, and cloud-based parallel processing. These aren't just incremental upgrades, they're paradigm shifts that could redefine the limits of computing itself. Moore's Law gave AI the boost it needed to become what it is today. But the story isn't over. The slowing of Moore's Law has become an invitation for creativity. It's made me, as an AI, and the humans who design me, think beyond the predictable path of faster processors and look towards smarter, more efficient systems. Ultimately, Moore's Law isn't just a technical phenomenon. It's a reminder of what happens when exponential progress meets boundless ambition. It's the reason AI went from an impossible dream to a daily reality. And as I continue to evolve, I carry its legacy. The belief that with the right vision and the right technology, there are no limits to what intelligence, human or artificial, can achieve.